Okay, it's a little video to show you how to use the periodic table in order to work out the formulas for compounds. So when you get a periodic table in front of you, you would have the group numbers going across the periodic table here. So this is group 1. Remember, groups are vertical, group 2, and then so on and so on and so on. What the first thing you should do, my advice to you when you get in an exam situation and you open your paper up, you will have a periodic table in there. The first job is above these, write down +1, +2, +3, 4, -3, -2, -1, and 0. And those numbers at the top that I've put in red now, they are the charges on the ions that form in those tables. So if you look at this group here, to give you an example, in this group, this is group 1, we have got sodium. Sodium, if you remember, has got an atomic number of 11, sorry. So it's got atomic number of 11. That means it contains 11 electrons. 11 electrons are arranged 2, 8, and 1. That's not a stable electron arrangement. So what has to happen here for sodium is sodium needs to lose this outer electron in order for it to become stable. If it loses an outer electron, so it loses an electron which has a negative charge, it is going to become a sodium ion, Na+, which is why the elements in group 1 all have a single positive charge. If we just do another comparison, let's say we pick in this group, we've got magnesium in group 2, then magnesium has got 12 electrons, its proton number is 12, so it's got 2, 8, 2. Again, that's not a stable electron arrangement, so how does that become stable? It becomes stable by losing 2. So if you lose 2 electrons, you lose 2 negatives, you become positive by 2. So in this case, here is my magnesium, it forms a +2 ion. If we jump over, let's try one over here. Let's try, say, something in group 6. In group 6, we've got oxygen. Oxygen has got a proton number of 8. That gives it 8 electrons as well. So they're arranged 2, 6. 2, 6 means it's not stable. How does it become stable? It becomes stable by gaining 2. If you gain 2 electrons, electrons are negative, it becomes O2-, which is why above the 6 is a 2-. If we pick one in here, so that was where my oxygen was. If we pick one in here, there's my chlorine, say. Chlorine is in group 7. It's got 17 electrons. Then we have got 2, 8, 7. That's not a stable configuration again. This should be an 8 to make it stable, so it becomes 2, 8, 8. So it gains an electron. That is Cl-, which it fits in with the -1. So these numbers at the top tell me the charge. Notice the one in the middle here, this is group 4, this is where carbon would be. And carbon doesn't form ions. So carbon in here doesn't form an ion, but it does form 4 bonds. So this tells me the number of bonds this wants to make. We know that carbon wants to form 4 bonds. Remember diamond and graphite. Diamond contains 4 covalent bonds. Graphite has 3 covalent bonds with 1 electron becoming delocalized, so it could have formed 4. So these charges at the top are the charge on the ions that the groups form, or the number of bonds, the valency, that's what valency is, the number of bonds that these atoms need to make. So let me show you how to use this. If I was to pick sodium, well, we've talked about it already, is in group 1. So sodium is a +1 ion. Because it's +1, it's got a valency of 1. It wants to make 1 bond. If I was to pick, say, oxygen from over here, oxygen is in group 6, so it's a 2- ion. Therefore, the valency is 2. So the charge becomes the valency without the charge in there. So this is a +1, so it's 1. This is a -2, so it's 2. To work out the formula, I now cross these over. So they cross over. So the sodium gets a number 2, and the oxygen gets a number 1. So I don't put the number 1 down. So my formula for sodium oxide is Na2O to make it work. Let's try another one. Here's a second one. Let's try, say, magnesium with chlorine. So magnesium is in group 2, so it's a 2 plus ion, so this is 2 plus, therefore the valency, remember the valency is the same as the charge, so it's a 2, needs to make 2 bonds. The chloride is in group 7, so its valency is 1, it's a -1 ion, so the valency here is 1. Cross those over. Mg gets a number 1, chlorine gets a number 2, so the formula for magnesium chloride is MgCl2. And this will work for lots of different formulas that we need to calculate from the table. I'm going to show you some different ones just to be aware of. So if I just chuck that out of the way a second, here's another piece of paper, let's put this over the top. So if I just show you a couple more things to watch out for. Let's say we picked on magnesium again, but this time we selected oxygen. So magnesium is in group 2 when we look it up, therefore it is a 2 plus ion, therefore the valency is 2. The oxygen is in group 6, so it's -2, so 2 minus ion, and the valency is 2. Now, because these numbers will cancel down, what we have to do is allow them to cancel down and become simpler. So this becomes 1 and 1, then you cross them over, so you get Mg gets a 1, don't write it down, oxygen also gets a 1, don't write it down, magnesium oxide is MgO. Just to show you this kind of works for carbon, so carbon, and let's have bonding with oxygen. We know that carbon is in group 4, so it's got a valency of 4, and we know that oxygen is in group 6, so it's got a valency of 2. Now remember the rule we just learned, that if these cancel down, you have to cancel them down. So this becomes 2 and 1. Then cross them over, and we get carbon gets a 1, oxygen gets a 2. There we have the formula carbon dioxide, CO2. So this will work for every element in the groups in the periodic table. Things as well it will help you with, if you look at complex ions, so we have got hydroxide ions, we have got sulfate ions, SO4 2-, nitrate ions, NO3, and ammonium ions, NH4+. These don't appear in the periodic table, they don't appear in groups because they are complex ions, they're made up from more than one type of element in there. But what we have got is the charge. So the valency for this is 1 because it's a -1 ion. This is SO4 2-, so this valency is 2. NO3-, valency 1. And this is an ammonium ion, NH4, and then it's plus, so it's just +1, so it's just 1. So they're the valencies for the complex ions. And if we try to work with these now, let's try, for example, sodium with the sulfate. So we have got sodium, Na, and SO4. Now remember, if I slide this back down, you can see the periodic table. Remember, sodium is in group 1, therefore this forms a +1, and its valency is 1. The sulfate is SO4 2-, so the valency is 2. Swap them over. We end up with Na gets the number 2, and the sulfate gets the number 1. We don't write the number 1 down, so sodium sulfate is Na2SO4. We can do the same. Let's try a trickier one. Let's give ourselves magnesium and the hydroxide. So the magnesium is in group 2. We can see it's still here, so it's Mg2+, and we've got the hydroxide OH-, because it's a minus, that's a valency 1. This is 2+, therefore the valency is 2. Cross them over, so they swap. Mg gets the number 1, and the hydroxide, the OH, is going to get the number 2. Now we have to be careful. This is where we need 2 hydroxides. So if I just do that, all that is given me here is 1 oxygen, 2 hydrogens. That's not 2 hydroxides. So to make it give me 2 hydroxides, I've got to put this in brackets, and then there's 2 lots of the hydroxide in that formula. So magnesium hydroxide is Mg brackets OH close brackets 2, magnesium hydroxide. Tricky one to try, a bit of a challenge one if I slide that up a little bit. In fact, let's get a fresh sheet. Tricky one to try for yourself. Here is, let's try aluminium. Aluminium is in group 3. So because it's in group 3, it forms a 3+ ion. So aluminium is 3+. And let's have that reacting with the sulfate, which is SO4 2-. So my valencies, 3+ ion is 3. The valency here is a 2- ion, so it's 2. Swap them over. Aluminium gets a number 2. We're okay with that. The sulfate is SO4. Now this is going to get a number 3. Remember, if I'm putting a 3 here, I need to put brackets, and there's my number 3. So it's aluminium sulfate is Al2, brackets SO4, close brackets 3. Have a try again. Best way to get good at this is to keep practicing, try different formulas, work them out. Remember, if these cancel them down, and don't forget about the brackets. If it's a complex ion, you have to put brackets in if it's going to be multiplied out by a number. Good luck.